Hello everyone, today we are going through some important questions of triangles. First question, in figure, if triangle ABC is similar to triangle DEF and their sides of lengths are marked along with them, then find the lengths of sides of each triangle. Okay, here it is given that these two triangles are similar. And we know that if two triangles are similar, then their corresponding sides are in proportional, right? That is, they are in the same ratio. Okay, so here we can write, since triangle ABC is similar to triangle DEF, their corresponding sides are in the same ratio, right? That is, AB divided by DE is equal to BC divided by EF is equal to AC divided by DF, right? Now, let's substitute the values. Here, what is AB? AB is equal to 2x minus 1 divided by DE is 18 is equal to BC 2x plus 2 divided by EF 3x plus 9 is equal to AC is 3x divided by DF is 6x. Cancel 1 by 2. Okay, so let's consider these two terms. Okay, 2x minus 1 divided by 18 is equal to 1 by 2. That implies 4x minus 2 is equal to, take this 18, cross multiply, okay, that is equal to 18. That implies 4x is equal to 18 plus 2, 20, that implies x is equal to 5. So here x value is 5. Now we can find the lengths of all the sides, right? Substitute x value. Here AB is equal to 2 into 5 minus 1, that is 10 minus 1, 9 centimeter. Okay, lengths are in centimeter. And next is, okay, let's find BC. BC is equal to 2x plus 2, 2 into 5 plus 2, that is 10 plus 2, 12 centimeter. Okay, next AC is equal to 3x, 3 into 5, that is equal to 15 centimeter. Next is DE, second triangle, DE is equal to 18 centimeter and DF is equal to 6 into 5, that is 30 centimeter, and EF is equal to 3 into 5 plus 9, that is 15 plus 9, 24 centimeter. If two poles 5 meter and 15 meter high are 100 meter apart, then find the height of the point of intersection of the line joining the top of each pole to the foot of the opposite pole. See here, two poles 5 meter and 15 meter height, and here we have to find, and this distance is 100 meter. Okay, now here we have to find the height of the point of intersection, okay, of the line joining from the top of each pole to the foot of the opposite pole. That is, we have to find the height of this line. Okay, see here, in last class we have solved a problem, that is, if these three lines are parallel and perpendicular to this line, and if it is x, it is y, it is z, then we have solved 1 by x divide plus 1 by y is equal to 1 by z. Okay, it's very important. If it is x, y, z, then 1 by x plus 1 by y is equal to 1 by z. So here we can apply this formula. Okay, 1 by x plus 1 by y is equal to 1 by z. We can substitute x and y values so that we will get required height, that is value of z, right? Okay, so 1 by 5 plus 1 by 15 is equal to 1 by z. 3 plus 1 divided by 15 is equal to 1 by z. That implies 15 divided by 4 is equal to 1 by z. Sorry, 4 by 15 is equal to 1 by z. That implies z is equal to 15 by 4 meter. So required height is 15 divided by 4 meter. PQRS is a trapezium with a PQ is parallel to SR, diagonals PR and SQ intersect at M, and triangle PMS is similar to triangle QMR. Prove that PS is equal to QR. Okay, so here it is given that PQ is parallel to SR and these diagonals intersecting point M. Then it is given that triangle PMS and QMR are similar triangles. Okay, since triangle PMS is similar to triangle QMR, their corresponding sides are in the same ratio. That is PM by QM is equal to MS by MR is equal to PS divided by QR. Okay. Now, let's consider two triangles PMQ and RMS. Okay. Triangle PMQ and triangle RMS. See, in this triangle, what about these angles? See, these angles are vertically opposite angles and these are equal. Okay. That is angle PMQ in the triangle PMQ, angle PMQ is equal to angle RMS. Okay. And next here, see MPQ, this angle and this angle are equal. Okay, alternate angles. That is angle MPQ is equal to angle MRS. MRS. Okay, two angles are equal. Therefore, by the AA criterion, we can say these two triangles are similar triangles. Okay, therefore, by AA criterion, triangle PMQ is similar to triangle RMS. Now, since these triangles are similar, their corresponding sides are in the proportional. That is PM divided by RM is equal to MQ divided by MS is equal to PQ divided by RS. Okay. Now, here, see, here we have PM by QM, right? So, let's make PM by QM. Consider only these two terms. That is PM divided by QM is equal to, okay, taking this one here and taking this one here, okay, RM divided by MS. So here PM by QM, let's take this equation 1 and it is equation 2. Okay, PM by QM is equal to MS by MR and PM by QM is equal to MR divided by MS. That implies, so from 1 and 2, we will get, these are equal, right? That implies MS by MR is equal to MR by MS. MS by MR is equal to MR divided by MS. That implies, cross multiply, MS whole square is equal to MR whole square. That implies MS is equal to MR. Okay. Now what we have to prove? We have to prove PS is equal to QR. See here, PS is equal to QR is equal to MR by MS by MR. Okay. See, from equation 1, PS divided by QR is equal to MS divided by MR. See, MS is equal to MR. That means MS by MR is equal to 1. Right? MS is equal to MR. Therefore, MS by MR is equal to 1. That implies PS is equal to QR. Hence, it is proved. In triangle ABC, DEF are midpoints of BC, CA and AB respectively. Prove that triangle FBD is similar to triangle DEF and triangle DEF is similar to triangle ABC. Okay, so here it is given that DEF are midpoints of AB, AC, D is the midpoint of BC and E is the midpoint of AC and F is the midpoint of A. Since these are the midpoints, here see EF is parallel to BC. Okay, EF is parallel to BC. Then DE is parallel to AB and DF is parallel to AC. Therefore, this BDEF is a parallelogram. Okay. Therefore, BDEF is a parallelogram. Here, see, we named these angles 1, 2, 3, 4. Okay. Since it is a parallelogram, angle 1 is equal to angle 2. Okay. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. Okay. Now, what we have to prove here? Triangle FBD. Consider triangle FBD. Triangle FBD and triangle DEF. Okay. Triangle DEF. See here in FBD, what is the angle B? That is angle 2 is equal to angle 1. Right? That is angle E. That is DEF. These angles are equal. Okay. And angle 3 is equal to angle 4. Angle 3 is equal to angle 4. Right? So here two angles are equal. Okay. In triangle FBD and triangle DEF, angle B is equal to angle B is equal to angle E and angle F is equal to angle D. Right? That is angle 3 is equal to angle 4. So by criterion, AA criterion, here these two triangles are similar. Okay. Therefore, by AA criterion, triangle FBD is similar to triangle DEF. Okay. Next we have to prove triangle DEF is similar to triangle ABC. DEF, triangle DEF and triangle ABC. Okay. Now, what is angle E and angle B? Angle E and angle B. See, angle 1 and angle 2. Right? So, here this angle is equal to this angle. Right? That is DEF. So, angle 1 is equal to angle 2. Here angle 1 is equal to angle 2. And next, see, angle, here, see, angle F and C. Angle F is equal to 3. It is a parallelogram, right? So, here angle 3 is equal to angle 6. That is, angle F is equal to angle C. Angle 3 is equal to angle 6. Again by AA criterion, triangle DEF is similar to triangle DEF is similar to triangle ABC. Hence it is proved. In triangle ABC, P and Q are points on AB and AC respectively such that PQ is parallel to BC. Prove that the median AD drawn from A on BC bisects PQ. See, here it is given that PQ is parallel to BC. Okay, here we have to prove AD is a median. Okay, and this AD bisects PQ. That means here let's take this R, then we have to prove PR is equal to QR. Okay, say since PQ is parallel to BC, by basic proportionality theorem, we can write AP by AB is equal to AQ by AC. Right? By basic proportionality theorem. And next let's consider two triangles APR and ABD. See, in these two triangles, A is the common angle and angle R is 90 degree, angle D is 90 degree. Right? So, by AA criterion, we can say these two triangles are similar. Right? That is triangle APR and triangle ABD. A is the common angle and angle R is equal to 90 degree and angle D is equal to 90 degree. Right? Therefore, these two triangles are similar. Then, since these two triangles are similar, we can write AP divided by AB is equal to PR divided by BD is equal to AR divided by AD. Okay. Now let's consider two more triangles, triangle AQR and triangle ACD. Triangle AQR and triangle ACD. See, here also angle A is the common angle and angle R is equal to 90 degree, angle D is equal to 90 degree. Okay. Therefore, by AA criterion, these two triangles are similar. Therefore, their corresponding sides are in the same proportion. So, here AQ divided by AC is equal to QR divided by CD is equal to AR divided by AD. Okay. Let's give this equation 1, it is equation 2, it is equation 3. Here AP by AB is equal to AQ by AC. And here AQ by AC is equal to QR by CD. AP by AB is equal to PR by BD. So from these three equations, we can write PR by BD. We get PR by BD is equal to QR by CD. Right? That is PR divided by BD is equal to QR divided by CD. Okay? From the equation, from equation 1, 2 and 3, we get PR by BD is equal to QR by C. See, here since AD is a median, here D is a midpoint, right? Therefore, BD is equal to CD, right? This implies here BD is equal to CD, that implies PR is equal to QR. Hence it is proved. See, PR is equal to QR. That implies, that means AD bisects PQ. Okay.